Titration is a really important analytical technique in chemistry, but can you write a good method for a titration? In titration, we're always working with two solutions. There's one solution that has an unknown concentration that we're trying to figure out, and the way that we do that is by reacting it with something else where we do know the concentration. I'm going to use a volumetric pipette to measure out exactly 25 centimetres cubed of the solution whose concentration I don't know. That's then put into a conical flask. Remember, conical, like a cone. The reason we use a conical flask is that later on we're going to swirl it, and the sloped sides of the conical flask mean that nothing is going to splash out. Meanwhile, my burette is filled with a solution whose concentration I do know. Firstly, we rinse through the burette with the solution we're going to titrate with to remove any impurities without adding water that would dilute things. Then we're going to fill it up so that the meniscus is on the 0 line. If we're doing an acid-base titration, then we're going to add a pH indicator to our conical flask. This will allow us to identify the end point when we see our first permanent colour change. That conical flask is placed on a white tile underneath the burette. Make sure you've got a few indicators up your sleeve, like methyl orange or phenolphthalein, and that you know which direction the colour changes will happen in. Don't forget, the colour change will be different depending on whether you have an alkali or an acid in the burette. We start off with a rough titration. So you're just going to add solution from the burette to the conical flask, swirling as you go until you see the first permanent colour change. Now let's say that colour change happened at 25 centimetres cubed. For the rest of your titrations, what you're going to do is for the first 20, just dump that solution straight in because you know you're not approaching the colour change yet. And then when you get to 20, you're going to be much more careful, and eventually you're going to add the solution drop-wise. As you're doing this, you should be rinsing down the tip of the burette and also the sides of the conical flask with a wash bottle full of distilled water. This doesn't affect our final calculations because when we come to finally work out the concentration, we're going to use the initial volume that we started with, that 25 centimetres cubed. So it's not taking into account any of the water that we've added. Each time that you reach the end point, you need to record your titer, and that's the difference between your starting volume and your end volume. Make sure that you're reading all of those volumes at eye level from the meniscus. You can stop the titration when you have two pieces of data which are concordant, and that means within 0.10 centimetres cubed of each other. Remember, all of your titers should be recorded to 2 decimal places, where the second decimal place is always a 0 or a 5. You can then calculate a mean titer and use this in your calculations to work out what the concentration of the solution in the conical flask was. Work out the moles that have come out of the burette. Then look at the coefficients in the equation to figure out whether that will be the same as the moles in the conical flask or whether you need to multiply or divide by 2, and then use that together with the volume of 25, converted to decimeters cubed, to work out the concentration of the stuff in the flask.